there. This is 725, another application, and it's actually one which at first glance you wouldn't think was going to end up being a quadratic, but it does. It's kind of cool. Okay, EdTech take tourists on dog sled rides. This one's out of the textbook. He needs to build a kennel to separate some of his dogs from other dogs in his team. He budgeted for 40 meters of fence. He plans to place the kennel against part of his home to save on materials. What dimensions maximize the area of his kennel? All right, so we have to build 3 sides of a kennel. So this one, I guess I should make my picture bigger. So this and this and this have to add up to 40 meters. And we want to have the maximum size. Well, first thing, what do you know about this side and this side? They should be the same length, right? Okay, so if we make this a width and this a width, and we'll make this a length. So what do we know? We know that, let's do it right. W width of kennel. Length of kennel. Okay, so we know W plus W plus L is equal to 40. Okay, so far that doesn't look like much of a parabola equation, but we need to talk about area. And area is length times width. You know that from before. But our problem here is we need to do something with this equation so that we only have it in one variable. How do I explain that? I think I'm going to solve for L. I'm going to make L in terms of W. Hold on. I'm going to erase this. I'll put it over here. No, I'm going to leave that for a second. And finish this. W plus W is 2W plus L is equal to 40. Or let's actually subtract the L. Nope, right the first time. I'm going to subtract 2W. So that means length is the same as 40 minus 2W. Or if I have 40 meters to start with, and I decide the length is going to be, or the width is going to be 10, then I need to double that, which gives me 20, which tells me how much I would have left, right? If I make this one 10, I know this one has to be 10, and then you would go 40 minus this one and that one to give you what's left over to be your length. Now we can do the area. Is length times width. And so my length is 40 minus 2W. And my width is just like width. So we're going to multiply through. So 40W, right? It's kind of backwards distributing here. Minus 2W squared. Aha. Now we're starting to look like a quadratic. Let me just rearrange that. So area is equal to minus 2W squared plus 40W. So we need to figure out what the width is going to be, and that should give us, we should be able to factor that and find out what the maximum is going to be. Actually, I better do some sketching. So this is going to be area, and this is going to be width. So my maximum area is going to be at my vertex. So P is equal to minus P over 2A. P is equal to minus 40 over 2 times minus 2. So P is going to be, brain fart, negative 40 over negative 4. There we go. P is equal to 10. So my width, oh, I lost the letter there. And I went too far down, sorry. It's equal to 10 meters. Now we want to figure out our area. Is equal to minus 2w squared plus 40w. Area is equal to minus 2 times 10 squared plus 40 times 10. Area is equal to minus 2 times 100 plus 400. Area equals minus 200 plus 400. Area is equal to 200 meters squared. So according to what we just figured out, and it was just frankly dumb luck that I picked 10 here. So if this is 10, this has to be 10. Okay, I'm doing a check here. Then this has got to be 20. Okay, and then area is 10 times 20. So area is equal to 200. Well, what if we made it so that this, okay, so my brain, I'll put it this, my brain knows the closer we can make it to a square, the better it's going to be. So what if we made it, okay, I'm going to go down here. And this is kind of my check. This is my dog kennel. What if we made, so these sides, in comparison to this, is pretty short. What if we made them 12 and 12, and then we go 40 minus 12 minus 12, and 16. So then area is equal to 12 times 16. 12 times 16 is 192. Slightly smaller than this. Well, what if we went the other way and made it even longer? What if, oops, I'm not scaling anymore. What if we made this 5 and this one 5? That would use up 10, which would leave this as 30. So area is equal to 5 times 30. Area is equal to, that's 150. So it actually looks like I can keep messing around. So this got close to the 200, but it looks like if I try and make it any closer to square, it doesn't get any better. And if I make it even less square, so 5 by 30, it's not going to work. What if I want to do one more? Okay, in case you're not sure, I'm checking right now. What if we do, okay, what's, I'm going to go 40 divided by 3 is 13. What if we do 13 and 13? 40 minus 13 minus 13 is 14. That's as close to square as we're going to get here. The area is 13 times 14. 13 times 14 is 182. Okay. So it looks like the math worked out perfect because I can't come up with a better number. Now, if you were having a really bad day on an assignment or something like that and you were struggling with this, you could always just start building kennels and keep changing the numbers around to see if you can come up with what's the biggest answer you can come up with. Remember in chapter 2, when we did reasoning, it was try something, so systematic. So if I was trying to do this systematically, I might go 12, and then I do 13 and see how it got smaller. So then I know this number has to actually go smaller, and I might try 11, and I might try 10. But it's way cooler, excuse me, when we do it this way, using the quadratic formula. So now he knows how to make the biggest kennel for his doggos. Oops.